Today we're going to talk about how to simplify radicals. So a radical is represented by a square root symbol. It's the opposite of an exponent. So an exponent would be me taking 5 squared and getting 25. Now we're going to take the square root of 25. So we're figuring out basically what I can multiply to get that number. The index tells you how many times you are multiplying the number. So the index goes in front of the square root symbol. If you were to see something like this, that means that the index is 3, and I'm trying to find 3 numbers that I can multiply to equal that. So for example, if there was a 27 underneath that radical, I can multiply 3 times 3 times 3 and get 27. So the cubed root of 27 is 3. We are going to only look at square roots. And so that means that the index is 2, but you usually won't see that 2 there. So when you see this, that means that the index is 2. These are very common square roots, okay? This is 1 through 20. So it might be helpful for you to go back and study these and become more familiar with them. That way, if you reach a problem where it's asking you to simplify a perfect square, you don't really have to do any work because you're already going to know what the square root is. So to simplify a radical, we are going to first make a factor tree. And a factor tree is where you're breaking down the number. So if we use an easier number like, let's say 12, I can break that down into 4 and 3. And then I can break the 4 down a little bit further into 2 and 2. Okay, so you're breaking down each number as far as you can go. We're not going to break down the 3 because it's only 3 times 1. So you want to get until you reach prime numbers. And you're going to see that there is more than one option because 6 times 2 also equals 12. Regardless of how you do it, you're going to get the same prime numbers at the end, so it's totally fine. There are a lot of different ways to make a factor tree. All right, then our saying is going to be couples get to go out of the house and singles have to stay in the house. So if we're looking at this example right here, I have a pair of 2s. That's considered to be a couple. So if I've got my house and couples get to go out, I'm going to have a 2 out in front of my radical. And then singles have to stay in. My 3 is the only single. Again, we're looking at the prime numbers that we ended up with. So since we already broke down 4, that is not included. So if you want, you can also cross out on these problems any of the numbers you broke down if you think you're going to mess that up. So 3 would be inside the radical. Okay? In the event that you have more than one couple or more than one single, you're going to multiply them together. So if I had another pair of 2s, I would multiply it by the 2 that I brought out front already. So example 1, we're going to simplify the square root of 24. So I'm going to start by making a factor tree. And again, you have multiple choices here. You could do 12 times 2, 6 times 4, 8 times 3. It doesn't matter what you choose. So let's say I choose 8 times 3. Then I can break 8 down into 4 times 2. And then I can keep going and break 4 down into 2 times 2. Okay, so you just want to keep going until you can't break any of the numbers down any further. So now you're going to look for your couples, so a pair. So I have a pair of 2s, and then I have a single 2 and a single 3. Okay, so when I'm writing my radical, my couples are going to go outside the house, and this is considered one couple. Okay, so you're not going to multiply that 2 times 2. That's one entity that's going to come out as a 2. All right, now I do have more than one single. I have a 3 and a 2. So whenever you have more than one of anything, when you're simplifying radicals, you multiply them together. So 3 times 2 is 6. So 6 is going to stay in the radical. And this is my final answer. Simplify square root of 96. Now in this unit, you're not going to be allowed to use a calculator. So a couple tricks. When you look at a number, if both of the individual numbers in that number are divisible by something, then you know you can divide by that. So for example, 9 and 6 are both divisible by 3. So I know that 3 is going to go into 96. So what's 9 divided by 3? 3. And 6 divided by 3 is 2. So it's 3 and 32. So now I can break down 32. We could do 8 and 4. And then for 8, I can break this down into 2 and 4. Now, if you get to this point and you already have a couple, you don't have to keep going. So I can go ahead and circle this pair of 4s as a couple. And then I'm done because I can't break down 2 and 3 any further. So those are my 2 singles. Okay, so for my final answer, couples go out, singles stay in. And again, this counts as one couple. So I'm going to have a 4 out front, and then my singles stay in. So 3 and 2, and if you have more than one, multiply them together. So you have a 6 inside the radical. And then this is my final answer. Simplify square root of 250. So if anything ends in a 0, the easiest thing to break it down into is something in 10. Just take the 0 out. So I can do 25 and 10. And then that's nice because 25 is a perfect square. So I can break this down into 5 and 5, and then that's already a couple. Okay, and then since 10 breaks down into 2 singles, you technically could have stopped there as well. That breaks down into 5 and 2. Okay, because when I multiply these two together to go inside, I'm still going to get 10. All right, so for my radical, couples go out. So this was my couple, that's going to go in front. And then singles stay in, and since I have more than one, I multiply them together. So I'm going to have a 10 underneath, and that's my final answer. Simplify square root of 72. So again, this is another one where you have a lot of choices on what you could break 72 down into. There's not a wrong answer. What a lot of students will do is anytime the number is divisible by 2, that's what they go with, and they just divide it by 2 every time. That's fine. Your factor tree will just end up being a lot bigger, and there's potential for losing those 2's in the process and kind of missing them as either a couple or a single. So the closer together that you can get your numbers to multiply to be that is going to make it easier. So 72 I can break down into 9 times 8. And then 9 breaks down into 3 and 3, so that already gives me a couple. Then 8 I can break down into 4 and 2, and then 4 into 2 and 2. And you guys are going to come up with your own tricks to help you. Some people like to carry down all the prime numbers or write them all off to the side, whatever you end up with. Some people like to cross out the numbers that they broke down. It's going to be kind of whatever works best for you. So I've got another pair of 2's here, and then we have a single 2. All right, so for my radical, couples go out. Now on this one, I have more than one couple, so I'm going to multiply them together. Again, don't multiply 3 times 3 and then 2 times 2. This is one couple of 3's. This is one couple of 2's. So that's going to give me 6 because 3 times 2 is 6. And then I only have one single. So that's left underneath the radical. And this is my final answer. All right, so on this next example, we are throwing some variables in there. Whatever you do, don't panic, okay? The variables are actually very, very simple. So I'm going to start with just breaking down the square root of 432 the same way that we've been doing the previous problems. So again, if you can't figure out what goes into 432, it's an even number. So worst case scenario, you can do long division and you can just keep dividing the numbers in half, okay? I am going to break it down into 12 and 36. And then 36 breaks down into 6 and 6, And again, once you get here, if you already have a couple, you can go ahead and circle these. You don't need to keep breaking down the 6. Okay, so now 12 I can break down into 6 and 2, and then 6 breaks down into 3 and 2. All right, so now I also have a pair of 2s. Right? The pair doesn't have to come from the same number. So even though the 2 came from the 12 and the 6, that's totally fine. That's still a couple. And then I have a single 3. All right, so couples go out, singles stay in. So I'm going to multiply since I have a 2 and a 6. 2 times 6 is 12. So that's going to be in front of the radical. And then inside the house is going to be the 3. Couples go out, singles stay in. And I'm leaving some room here because I need to add my variables in. So for the variables, I'm going to show you the long way first, but then as you guys get more comfortable, you're going to be able to do these in your head. So if I think about x squared, that means I have x times x. Okay, that's what x squared represents. Well, how many couples is that? That's one couple. So that means that I'm going to have one pair come out because couples go out. So I'm going to have x in front of my radical. Okay, easy enough. So now for y, I have y times y times y because it's y cubed. So if I find my couples, I have one pair of y's. So that's a y that's going to be in front. And then I also have a single y. So that's a y that's going to be inside because couples go out, singles stay in. So essentially what's happening is you're dividing the exponent by 2, and then if you have a remainder, that is a single, right? So if you have 3 people, for example, if you try to cut that in half, you're going to get 2, okay? But then, or 1, excuse me, that one pair, and then you have a single y left. All right, so for z, if I write out 10 z's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then that is going to give me 5 pairs because 10 divided by 2 is 5. So 1, 2, 3, 4, 5 couples and no singles. So if you have an even exponent, you're not going to have any singles. So since that was 5 z's, I'm going to bring all 5 of those out. So that's going to be z to the 5th power. And that is my final answer. So our last example, we're going to simplify the square root of 500 p to the 7th q squared. So again, when you've got variables, just start with the number first. And again, if it ends in a 0, you can always just divide it by 10, or in this case, you could even do 5 times 100. So I'm going to do 50 times 10. And then 50 I can break down into 5 and 10. So now I've already got a pair of 10s, and then I have a single 5. So I didn't need to make this factor tree too long. So couples go out. I've just got one couple, so I don't need to worry about multiplying. So 10 is going to be in front, and then I have a single 5. All right, so now for the variables, again, you're not going to have to write them out every single time. So if I have 7 p's, how many couples can I make from that? Well, you know you're going to have a single because it's an odd number. So if you take the single out and go ahead and put him inside, then that would leave me with p to the 6th. So if you have 6 variables or 6 people or however you want to think about it, if you've got 6, how many couples can you make? Well, just divide it by 2. It'd be 3 couples. So p to the 3rd power is going to come out front. All right, so then q squared, if you've got 2, you're not going to have any singles. There's no q left underneath. And then 2 divided by 2 is 1, so you're just going to have 1 q out in front. And then this is my final answer.